Given the force versus displacement graph below for a net force applied horizontally to an object of mass m that's initially at rest on a frictionless surface, determine the object's final speed in terms of F max, these R1, R2, and R3 points, and mass. You may assume the force does not change its direction. Well, we've got a force versus displacement graph. If we want the work done, we could take the area of that, and if the work is the change in kinetic energy, we can go from there to solving for velocity. So, work is going to be the area under our graph, which is 1/2 base times height, plus length times width of this second rectangle, plus 1/2 base height for this third triangle, the second triangle, our third section of the curve. This implies then, well, we've got 1/2 R1 times F max plus, well, this distance here is going to be R2 minus R1 times our height, F max, plus 1/2 our base here is going to be R3 minus R2 F max. And all of that has to equal 1/2 mv squared by the work energy theorem. This implies then that velocity squared, we can multiply everything else by 2 over m, is going to be, let's factor out an F max over m, and I would get, well, what all are we going to have here? We're going to have an R3, we've got a minus R2, we've got a plus R2, so we'll have plus R2 minus R1, which implies then that our velocity is going to be the square root of all of that, which will be F max over m times the quantity R3 plus R2 minus R1 square root. So we can get to velocity even from the area under a force versus displacement graph. All right, hopefully that gets you a good start on work. Thank you so much for joining us at Educator.com. I hope to see you again real soon. Make it a great day, everyone.